Everyone, welcome to this another video, and in this video we will be discussing about subset sum problem. It is also a type of a knapsack problem, but it omits one of the arrays that we had in knapsack, where we had two arrays. One was a value array, which we had to maximize, while we had another array that was a weight array, which we were trying to fit into the knapsack. So here in subset sum problem, we are given an array, and using that array, we have to find whether we have a subset available in the array which sums to a number that is provided. For instance, in this particular case, we have an array 3, 34, 4, 12, 5, 2. We have to find whether this sums to number 9. So if you traverse it, definitely there's a number 4 plus 5 that gives us 9. So our output is true. Right, so if we see that at every indices of this particular array, or for every element of this array, we have a choice whether to include that as a part of a sum or not. So I can either include 3, or either can not include 3 or exclude 3. So we see that similar to knapsack, we have a choice here. So what we do, we already have built our matrix in knapsack. So similar to that, for each cell in that matrix, we are going to calculate whether to include that particular element from the set, or exclude that, and then based on that we will be arriving at our final sum, that is 9 in this particular case. So let's build our matrix first. So our matrix, so let's create another function. So that function, this takes an int value that may be a size. We will see whatever is required. So set underscore sum. We will create our matrix or a cache. Again, that's similar to whatever we did in our knapsack solution. So holds type int, and what will be the size of this matrix, how many rows will be there, will be equal to the size plus 1 of this particular set. So I will just use it as int plus 1, and then I am going to just create each rows with all the columns, and columns will be from 0 to all up to 9, because we are going to solve the subproblems and build on those subproblems to get our final answer. So here, range of matrix. So instead of cell, just take J maybe. So matrix of J will be make the int, and size will be, as I already told, sum plus 1. I will also pass sum here. Now what will be the base condition here, right? Say our sum is 0. So is there a way to have a sum when sum 0? Yeah, we can have a sum 0 if we do not include or have an empty subset, right? So in case of an empty subset, we can get sum 0. So another base condition will be my set is empty. So in that case, is it possible to have a subset which sums to any number? No, right? So that's again a false base condition. So let's iterate over this matrix. Matrix for J range of so right. So if JJ represents your weight, so I'll just use or sum S, right? So if S equals to 0, what happens? My matrix of I comma S will be true, right? I can have an empty subset. Okay, I have to create it as a bool array because we are only finding whether there exists a subset or not. In case my we'll be returning it false. In case I have empty set, I cannot have sum, right? And this one is in case I have sum equals to 0, I can have an empty subset. Alright, so going forward, now another case is simple, similar to our knapsack. So if at any time, or if my matrix, I will just say an item matrix, if items of I minus 1 is less than equals to the sum, yeah, then I can either include it or not include it. So ij will be now solve it. Check the subs. Another one will be, okay, I have an S matrix of I minus 1, and S will be now S minus items of I minus 1, or I do not select it. In that case, matrix I minus 1, it will be just S, and another one will be else. Again, I do not select it. Right. And my final answer will be matrix of n comma sum. So let's call entering this, just show this, n will be len of sum comma sum, let's say sum in our case, and I pass my sum value and subset sum. Yeah, now let's call this. Oh, we panicked somewhere. Let's see what's the problem. Here, items of I minus 1 is less than equals to sum. So we are iterating from 0 to n plus 1. Just enter it like this. Sorry, some issue here. Let's see it again carefully. So my n will be n plus 1. So it's len. Len will be total number of elements in the array, but I have extra 0 for the base condition, so my size will be n plus 1. And the sum, but I'll be having 0 to 9. So as a result, my particular size will also be equals to sum. As a result, I always will be pointing to items of I minus 1. S minus items of I minus 1. So this looks fine for me. Oh, so in case we have arrived at this condition, we do not want to process it further, right? So let's run this again. Still a problem. If s is equals to 0, then we can definitely have the sum. Equals to false. If if items is less than equals to s, that was the error. So now we see that we definitely have a subset which has sum 9, right? Also, let's try for another so that we are sure that our answer is correct. Right, this is also true. Oh, do they? It's 5 plus 4. Let's change sum to 30 also. It returns false, so that's the correct output. Right, so let's also 12 plus 4. Let's try for 16. Okay, so it seems that this works, and we have also seen that it overlaps kind of similar to Knapsack. Only thing is we are not maximizing anything here, but our choice criterion is still the same as Knapsack. Okay guys, so this is it for today's video. We will be covering few more problems that are similar to Knapsack, so that we have practice enough onto the problems of type Knapsack. Alright, have a nice day. Bye bye.